for taking this cloud session for my students. Thank you so much. So over to you. Thank you.
Yeah, I'll just share my screen as well. So, I hope you can see the slides.
Yes, I can. Thank you.
Okay. It's only the slides and not the notes and other stuff, isn't it?
Yes. Yeah, I'm in cloud concepts, and then I can see his disclaimer. Those two things I can see. That's all.
Oh, those two things. So it is not this screen that is getting shared. Okay, because I have two screens here.
Okay.
How do I do this now? Okay, let's get started. I'll be in this mode only.
Okay.
Okay, so I'm Rupesh. I am also an ex-CUSAT person. I graduated in 2001. We were the third batch of School of Engineering, and I was in Electronics and Communication, and Maya was from IT. And from then onwards, I've been working with various multinationals, mostly with HPE for more than 16 years. My areas of interest are mostly into security, and recently I completed my M.Tech in data science and engineering from Pilani. So, cloud is something which has been of interest for a long time. I used to take sessions on cloud computing and cloud security specifically for corporates from HP. So I used to do a 2-day workshop kind of thing for corporates, 1 day full theory and 1 day full practicals on AWS and OpenStack. This talk I'm going to take is kind of the first hour of the first day that I usually take. So I have changed the slides from our corporate to non-corporate. I have taken a template from fppt.com, and the disclaimer is that all that I'm going to talk today is my own views and should not be attributed to my organization or my employer or the committee or groups that I belong to. What am I going to take today? A brief definition of cloud computing. Okay, what are the characteristics of cloud infrastructure? And what is the idea economy? Okay, and some references and question and answers. So everybody has their own definition of cloud computing. Okay, so what happens is that everybody wants information anytime, anywhere. Okay, so for example, you need WhatsApp to be accessible all the time, and data right now is kind of segregated into two types. One is the structured data, okay, and another is the unstructured data. I think if I keep this in this mode, you might not be able to read the slides, isn't it?
Yes, that's right. It's not coming, pretty big. It's we can read it, but
yeah. Just 1 minute.
Sure.
Yeah. How about this?
Yes, that's good. That's great.
Okay. Is it good now?
Yes, it is.
Okay. So you might not see me on the camera because I'll shut the lid of my laptop.
Yeah. Okay.
Yeah. So data, as I said, is structured or unstructured data. Okay. So, and to make this data available, okay, you need to have a lot of infrastructure in place. And that is, you need to have the reliability, distributed computing. Data should be distributed so that it is available all the time. Okay, anytime you want to. You need to have proper security built into the access of the data. You should have redundancy built into it, and it should be performing quite well. Okay, you guys might be using the internet quite fast. But when we were in college, we used to click on the URL and wait for a few seconds for it to load. So that and all is not acceptable in today's time. So to make the data available anytime, anywhere, a lot of cost is involved. Okay, so there is an infrastructure cost. Okay, that is basically the hardware that is being procured to make that data available. Okay, you need to have licenses for different software or operating systems that you use. You need to have power and cooling. Okay, so if you are having a data center, you need to not only provide the power for the servers generate a lot of heat, so it requires cooling also. And the maintenance and operation costs, you need to hire the person to actually maintain the infrastructure. So and based on different business requirements, this cost might go up, or for example, a small and medium business, this cost will be very less. Okay, but these costs exist, okay, in terms of making the infrastructure. And what if I said that with cloud computing, a lot of it goes off? Okay, so that's what we are going to see. How is it going to go off? Okay. And when I talk about cost, there is something called as the operating cost, and there's something called as the capital expenditure cost. So capital expenditure, in short, people call it as capex. Okay, so capex is like when you want a computer, you spend some money to buy that computer. Okay, so you spend like suppose 50,000 for a laptop. So that is your capex. That's the initial investment. But to get that computer running, okay, you have to spend for the electricity that you consume. You have to spend for the internet plan that you use. So those things are called OPEX. Okay, so those are like operational expenses. Now with cloud computing, the capex kind of almost goes off. Okay, so it's only the operational expense is what you need to spend for. Now let us see what are the technologies that enable cloud computing. How did this whole thing happen? Okay, and what is it about? So the basis or the mother or father of the cloud computing is virtualization. Okay, so everything is a virtual resource. Okay, so traditionally you have been virtualizing the virtual CPU, okay, and memory, virtual memory, and all. Okay, and servers, we have partitions and virtual machines, and in modern times we go for others. So let me just shift gears a little bit and explain to you or give an introduction of what is this virtualization. So virtualization is nothing but making one thing look like many things. Okay, so if you notice, a lot of time your computers spends in idle. Okay, it's not utilized much. So you can actually make use of the hardware to run multiple computers on your real computer. Okay, for example, here I have used a package called Oracle VirtualBox. Okay, I hope you are able to see my screen.
Yes, we can.
Yeah, so this Oracle VirtualBox is kind of virtualizing my real hardware. Okay, and so what do you need in a computer? You need a compute, you need a network, and you need a storage. Okay, so all three can be virtualized. For example, here my actual hardware is running Windows, and because of this virtualization, I also have a Ubuntu running here. Okay. Okay, you can see that it's an Ubuntu instance which is running, and it is inside my laptop where I have Windows and I'm running a Ubuntu also. Okay, now how did this happen? So this is because of the virtualization layer provided by VirtualBox. So it gives me, if you go into the settings here, you can see that it gives me a processor. So my processor, suppose it's kind of an 8 CPU laptop, and 8 cores are there, and 1 core I'm using for this Ubuntu. And storage also, I have a virtual disk over here, okay, and networking, for example. So my laptop generally, like, it has just a wireless network connected to it right now. It also has a physical network, but you can see that I have 4 network interfaces available to me on this virtual machine. Now, since this is running, I cannot make much changes here, but it has virtualized the network interface and provided me 4. So I can make it in different configuration, NAT or bridged, or depending on the requirement. And like that, I can have multiple virtual machines running here, okay, as long as I don't reach the physical limits of the underlying hardware. Okay, for example, I can run probably 4 CPUs, because otherwise it becomes red. My host operating system will not have enough resources to manage. So this virtualization actually is the bare bone requirement for the cloud to happen. Okay, and let's go back to our slides. And we had the virtualization of the CPUs. Okay, so now there are process level virtualization, where you have application virtualization, network virtualization, and you have a security to be built all around it. Okay, and so these are also called as logical environments. Okay, because we are kind of grouping them into different categories with certain kind of compartmentalization. So you would have heard of Dockers and Kubernetes and all. So that's kind of a management of the logical environment. So what are the benefits of virtualization? Okay, so let me give you so slide deck. Can I move this? Yeah. So we consolidate the whole workload. So workload means an application running on your hardware. Okay, we can consolidate a lot of it. Okay, we can have a secure environment. You can have multiple OSs. You can have built-in disaster recovery and easier to manage. And these are all the benefits which the cloud took benefit of. Okay, just to these slides will be shared with you, so you can go through it, I think, later. So just an example of the benefit of the bare bone virtualization. This is without cloud computing. Okay, before virtualization they had 190. So this is a real example. Okay, so there were 190 racks. So what is a rack? A rack is nothing but an almirah where you keep all your servers, storage, and network equipment inside a data center. Okay, and these almirahs will take square feet of area, so you need to rent that much, or you need to buy that much of real estate. Okay, and you can imagine if so many almirahs of computers are there, okay, they would consume a lot of power and they would emit a lot of heat. Okay, so it requires power and cooling also. So this was the carbon footprint for these many racks. After virtualization, you had the same number of computers, okay, but they had been consumed in just 14 racks or 14 almirahs. They consume less square feet and they required less power and cooling. Okay, so that's the benefit of virtualization. That's what has fueled. So this didn't happen overnight. Okay, virtualization has happened over many decades. Okay, and cloud computing happened in the last decade. Okay, though I'm taking the session now in 2021, this cloud computing got popularized almost a decade back. So many people have different definitions of cloud computing, but there's a standard definition that everybody needs to understand before we get into the details of actually what is cloud computing. So NIST stands for National Institute of Standards and Technology. It's a US federal body which defines many of the computing standards. Okay, cloud computing being one. The NIST definition of cloud computing is just a 3-page document, actually 8-page document, but others are all statutory things, and 3 pages are the definition. So this is what it says. Okay, and anything that has to be called as cloud computing has to have these 5 essential characteristics. Okay, we'll go into each of these in more detail in the coming slides. Okay, these are called the essential characteristics. Okay, and next is something called as a service model. Okay, so you would have heard of IaaS, infrastructure as a service, PaaS, SaaS. We'll go through these also in more detail. And the deployment models, private, public, hybrid, and community. So you might have heard of all these three, but not community. So, but these are the deployment models. We'll go through each of these in detail. If not anything, you should understand what this is. If something doesn't have these 5 characteristics, it cannot be called as cloud computing. For example, virtualization, which is the bare bone for cloud computing, cannot be called as cloud computing because it doesn't have all of this. It has some of this, but it has not all of these properties or essential characteristics. So let us get into the essential characteristics. Okay, something to be called as cloud computing has to have broad network access. Okay, you should be able to access it from anywhere. So the anywhere, anytime thing that I told at the beginning of this talk is actually a characteristic of cloud computing. You should be able to access it from your mobile, from your laptop, from your any computer that has internet connectivity. Okay, so you should be able to access from the remotest of village, from the remotest place on earth, and it has to have that. Next is rapid elasticity. Okay, so rapid elasticity is like if the demand increases, suppose you host a website, many users start using it, and the moment number of users increase, okay, it should be able to just service them without any requirement to change anything. Okay, and suppose like in COVID times, okay, a lot of people a lot of business went down, not so much activity. So you should be able to shrink also the demand. Okay, for example, one example that I usually give is if you are booking a ticket for bus, you generally use redbus.in. Redbus.in is fully on the cloud. Okay, they don't have any equipment other than the laptops for their employees. Okay, so during the COVID, travel was fully blocked. So you need to shrink and not consume the. So that is one of the another property of cloud computing. Then everything should be measurable. Okay, so it's a measured service is the third property. If how much compute you are using, how much network bandwidth you are using, how much of storage are you using, so everything should be measurable. Okay, and that is a important criteria. Otherwise, how will you know who is using what? It should be on-demand self-service. Okay, for example, there should be no human intervention. And I'll be showing you a demo where I'll be demonstrating how this is all happening. Okay, right now, and that is also an essential characteristic. It should all happen at the click of a button. Okay. And resource pooling. This last but not the least is very, very important. Okay, so how do you make all these other things happen? For example, the rapid elasticity. Suppose you want to increase the capacity of the number of users that are visiting your website. Okay, you should have the capability to pool in resources. For example, my laptop that I showed you has a capability of only 8 CPUs. Okay, but suppose I am hosting a website on my laptop, and suddenly the user base goes from 100 to 1000. Okay, so I should be able to plug in other computers, okay, and that should not affect those users which are already connected to my laptop. Okay, and that happens through the virtualization layer, and there are a lot of other background things that make it happen. So you should be able to pull in multiple hardware, okay, and make them seamlessly available for the environment. And the virtualization layer helps in that a lot of ways. So next, let's look into what is called the service model. So that was the second thing in the NIST definition of cloud computing. So infrastructure as a service. Okay, so what is this? So this is nothing. So these slides are taken from Cloud Security Alliance. Okay, infrastructure as a service is nothing but just the virtual version of your real hardware. Okay, nothing beyond that. So the example here is AWS. AWS gives you almost the virtual version of the real hardware, and they also give the operating system, but we can consider it as part of IaaS. So this is like the real hardware that you have, and all this you need for developing some software. So next comes the platform as a service. Now, uh, we have still not reached the software now, okay, but to run the software you need some bare bone things. Okay, for example, if you're running a website, you need the Apache web server. If you need a database, you need a MySQL or an Oracle database. So all that is called the middleware. Okay, so middleware along with the virtual hardware is kind of giving you a platform to develop your software. Okay, so example here for platform as a service, Cloud Foundry, okay, which is now a VMware company, and we have still not reached the software. Okay, then this is something that you're very familiar with, software as a service. So this consists of the virtual hardware, the platform, and the software. So example here is Gmail. Okay, so or WhatsApp or Facebook. All these are software as a service. Now, as you go from IaaS to SaaS, okay, your control over the offering reduces a lot. For example, here in IaaS, you can install whichever web server you want. Okay, you can configure it the way you want. Okay, and whereas when you get into the software as a service, you don't have that much of control. For example, Gmail, okay, you cannot even encrypt your emails. I don't know if that capability is built now, but as far as I know, it was not built. So the control is very less. You cannot change much the look and feel of your Gmail account or your WhatsApp. You are restricted to how they're using it. So I'll not spend much time on the definitions part of it. I'm just giving an introduction so that people come up to pace who have not attended cloud computing classes and all. And this is more in details about the same thing, IaaS, okay, and the PaaS and the SaaS. Okay, now let us get into the deployment models. Okay, so anything that is available over the internet, okay, that is called the public cloud. Okay, for example, AWS or GCP, Google Cloud Platform, or the Azure. Azure is available as a public offering, azure.com. So these are all public cloud where you can go and get. So I'll be doing a demo of the public cloud in some time. Okay, then you might want to take benefit of the cloud computing framework or the concept itself in your organization, but you don't want to expose it outside. For example, you have different divisions inside the organization, like the HR department, or for example, CUSAT. CUSAT will have multiple departments. One will be computer science department, electronics department, and they all want to work on different machines, okay, but they don't want to use the AWS or the GCP. So they can have built their own private cloud, okay, and from that they can provision the machines to the departments which are wanting to use that. That's a private cloud. And so here I gave example of AWS and all. So this private cloud, OpenStack is a framework which is used for private cloud. Azure also can be used in a private cloud environment. It provides that capability. Something that is a combination of private and public is called the hybrid cloud. And generally, people are going for an hybrid cloud. For example, if you have a website, okay, so the front end of the website, you might want to put it in the public cloud, but important information about the users, their credit card information, and all you want to store in the private infrastructure. So you will use a combination of these two, and that's called a hybrid cloud. Community cloud. So community cloud is where a like-minded set of companies come together, pool in those resources, and build a cloud which can be utilized by all the people who are part of that community. For example, generally I give here a non-IT example. In Japan, for example, you have workforce who work in Sony company, which makes TVs and all, and you have Honda, which makes cars and vehicles. So in certain seasons, there's more demand for cars, and the workers from Sony will go and work in Honda, and when there's more demand for making TVs, the workers from Sony will go, from Honda will go and work in the Sony. So that means it's a community with like-minded people, and they are sharing the resources. So that's kind of a community cloud. Some data here which you might not find in your textbook, so I thought I'll share. So AWS is kind of the leader in the cloud market share. Okay, Azure is next, GCP is third, but GCP is gaining a lot. Okay, this data is a bit dated, 2 years old, and there's something called as Alibaba Cloud, also mostly popular in China. Oracle Cloud is trying to push in a big way. I don't know. Okay, and but these three are the big ones. Okay, and if you see over the years the market trend, okay, so GCP, though it was there long back, it was not so popular, but GCP is kind of gaining in 2020. It is gaining a good market share. AWS market share is reducing, okay, and it is being eaten up by either Azure or GCP. In India, GCP is pushing a lot. That's why I think you also got a lot of. So they're giving a lot of free trainings, and all. It's almost the same. Okay, AWS, GCP. It's just that everyone has their own offerings and the costs involved and all. So a lot of companies are going for multi-cloud. Okay, so what is multi-cloud? So, for example, when you want to take the benefit of the cost for different reasons. For example, the compute is provided by AWS as well as GCP, but you would want to see which is costing you less, then you would host your compute requirements in AWS, for example, and yours is a AI ML based solution. Okay, so your app is using a lot of analytics, and also the analytics capabilities are much cheaper when you go for Google Cloud. Okay, so the analytics capabilities you'll utilize from Google Cloud, and but you will host probably the data in Amazon S3, which is the storage, so which is much cheaper. So like that, you use multiple. You not only use AWS, you use GCP, and you have multiple clouds. Plus, you also want to use your private infrastructure, and that's when you get into this multi-cloud and hybrid space. This also is a bit old survey, okay, 2015. But it shows that people are in different domains. Okay, so these are like manufacturing, telecom, retail, finance. People are going for a mix of the private and the public cloud, and on an average, like 25% is in the public, and still 70% is in the private cloud. So let us go for the next. Okay, so what is this hybrid infrastructure? Okay, so you have this on-premise. On-premise means within the company's premises. Okay, so you have the private clouds and you have the traditional IT, which you have hosted some critical old application which has been running for a long time. For example, Tata Steel's manufacturing automation computer has been running for the last 20 years. Okay, so you cannot change that overnight. Okay, you will stop the steel production. Steel production has not stopped. So steel production is something which is very critical. It cannot stop suddenly. Okay, so because to fire up that furnace and all, it takes multiple months and years. So something like that. So but you still want to take benefits of the cloud. So you go for off-premise things like the public cloud and the managed clouds. Now, when you go for cloud computing, one important aspect of that is the regulatory compliance. Okay, so when you get a computer, which is a virtual computer, okay, it has a storage, it has networking, but where is it really stored? Okay, which geographical location it's stored? So we are talking about good things, but there are a lot of bad people on the internet. Okay, who also take advantage of all these technologies. So suppose a crime is committed. Okay, there's a hacker who hacks into your organization. So which law Okay, so suppose we have the cloud for India, okay, and the hacker is probably from some other state, okay, but you got hacked while you're in Kerala. So which law will govern that? I know the Indian law is the same for all that, but suppose you go across countries, okay, so every country has different laws. So how will you go for the regulatory compliance requirements? That's a big challenge. It's still a challenge for the cloud computing. That's why not many people go for cloud computing, but people have found ways to uh, work around these things. One thing important you need to understand when you go for cloud computing is that you need to be very familiar with all the open source software. The whole cloud is kind of making use or giving capability to run a lot of open source software, and the more you learn about it, more you'll be able to take advantage of the cloud concepts. So what makes it all happen is the concept of multitenancy. Okay, so if not anything, you should take this back after this talk. Okay, what is multitenancy? Tenancy, you might know. So tenancy is like when you rent something, you become a tenant. Okay, and for example, here we actually kind of rent the hardware. Okay, rent the virtual machine. Okay, and so there is a concept of segmentation. Okay, where everybody who rents it is segmented. The other people are not allowed to see. So you have your own space out there. Okay, so that is why the segmentation isolation is provided. There's something called as the governance. Okay, so for example, you can do certain things, you cannot do certain things. You cannot use probably certain clouds. So a lot of people are using clouds for mining cryptocurrencies and all that. So there are some governance or for hacking. Okay, so once if it is found, that will be kind of taken off. Cryptocurrency also is valid if you're ready to pay for it, but hacking and all is generally, if somebody finds it out, they kind of take you off the cloud. There are service level agreements. For example, when you are in a PG, and so that's a kind of a multi-tenancy. Okay, multiple people are staying in the room and sharing the accommodation. So you have service level agreements, like if the tap is not working, it has to get service because you're paying for it. Okay, so then there are different billing models. Okay, so based on how much meals you take and all that, like that, in how much compute or networking you take, you have the billing models. And this is all actually policy driven. Okay, so there are policies for everything, how much you can use, how much you cannot use, and all. And that is the multi. One example that I generally use is the Zoom car. I don't know if it is still surviving, but uh, is kind of a replication of the cloud computing in the real world. Okay, you don't have to have any capex for riding a BMW or a Mercedes or Audi and all. You just need to pay for how much hours you're using it. Okay, and you rent the car, you use it, and you give it back. Okay, and that's the best example I can give analogy for cloud computing. So let us see how this is in action in AWS Cloud. Okay, so I'll be showing so what I'm going to do now is I'm going to launch a website with the click of a button. Okay, and we'll see how it goes. Okay, and hope the demo daemon doesn't come up. Okay, so demo daemon is something which we say that when you're really going for a demo, it will be popping up. So when you go for aws.amazon.com, so this is the AWS website where you need to sign in and you need to access your console. Okay, and it has all the capabilities. So I have got a free account here, and as you can see, my location for the data center is Mumbai. We'll get into all that. So the services available. So it has got many services available. Okay, you have the compute. As I said, there's a storage, S3 storage. There is database. RDS database, we'll talk about it sometime. We have other capabilities, okay. There are developer tools, there are analytics, okay, which you can use, analytics capabilities. And this whole machine learning is separately, because analytics and machine learning are separate. You have IoT services also. I'm not seeing that here. You have container services, okay. And you have many of these, but we won't be using, we'll be using something called as the Elastic Compute Cloud. Okay, so let us go there. And I've been talking a lot about doing things on the click of a button, not requiring capex and all that. So let us see whether we can really make use of, or I can actually show you all this. Bit slow today. Yeah. So this is my dashboard. Okay, EC2 dashboard, where I have something called as key pair, which I created security groups. And so what we are going to do is we're going to launch an instance. Okay. And when you go for an instance, it's generally not this low. Okay. I had checked it yesterday also. So I have 0 instances running. Or I can do a launch instance from here also. So I'm going to launch an instance, okay, launch instance, and then it will give me capabilities, what all I want. So by default, it is giving this Red Hat Enterprise Linux, SUSE Linux. You can also have a Windows system. I used to do a demo when I just have a computer. So when people generally see that, okay, you will get a Linux, but you can't get Windows. I can do that also. Today, what I'm going to launch is I'm going to have a website. Okay, so it's not just the computer. I'm going to have a web workload there called the website. It's going to be a blog website, which is basically a WordPress website. So this is one free tier eligible website instance. So these are all templates which are built in, which I can select. So I'm going to select this WordPress instance template. As you can see, I'm going to use the free tier one, okay, because I don't want to spend money for doing this demo. But if you have money, you can have a very large capability for this website, and based on the hours, the money gets charged for you. So, and now it will show me. So I'm going to go for a micro one, which is free trial eligible. So I'm going to use that for this demo, okay. And if you have money, you can go. So you can see the number of CPUs which I'll be using. Now this one has only one CPU. The kind of storage, the GB. Okay, so this is the RAM. Okay, and this is the internal storage, which is the hard disk. Okay, so and if you are able to pay money, you can go for very high RAM and hard disk and all. And you can also have SSD versions. For example, here you have SSD and this many GBs of RAM and all that. So let us go for the free one and let us see whether it really does review and launch. So mine is, I'm just going to launch this. It will ask me if I'm, so I had a key pair already. So this concept of key pair, which is used when you want to really access this. So I'm going to use my existing key and the launch instance. So while this is happening, let us go back and show you what is happening in the background. Okay. So what are the AWS components? Okay. So this is the AWS website where I connected as a user, and when I log in, I actually get and I instantiated an EC2 compute. So I'm getting serviced by something called as a virtual private cloud. Now, what is this virtual private cloud? It's kind of a segregation for me. And the example I generally give here. So these slides I have taken from something called like Linux Academy. I've given the source in the reference also. So let us understand what is this virtual private cloud. Okay, example I'm going to take is Netflix or Amazon. Okay, and here it is Netflix. So when I log in, okay, into the Netflix, okay, I have a specific geolocation and I have certain preferences, the movies that I have watched, so those are all stored in a database called RDS database. And when I want to watch a movie, okay, it has to get um, service to me, okay, it has to get streamed to me, and that is done by the EC2. So suppose another user comes in, okay, he logs in to the Netflix and he wants to watch movie. So he'll have another his own VPC, okay, where he'll have his compute instance and his preferences stored in the database. Now, let me go here. Okay, so as I said, VPC is nothing but a virtual private cloud where this is the compute, this is the storage. Now, this is the storage of the preferences and also, for example, customer info, inventory log, what all movies I've watched, not watched, all those customizations things. When I want to really watch a movie, okay, so what happens is that they don't want to store the movie for each person who is connecting. Okay, so the movies, so for example, any movie would be around 4 GB if it is a DVD kind of a format, and or GBs. Okay, so they cannot have GBs of storage allocated for each virtual private cloud. What they do is that the large storage they store in S3, they call Amazon S3, which is for mass storage, long-term storage. So even when I'm gone, the storage will still be there. Okay, I'm gone as a user, but different users want to watch the same movie. It will take it from here, from the storage. It will do the encoding, decoding, and stream the movie to you. Okay, so that's the kind of things that are happening. That's the concept of virtual private cloud. And this actually I wanted to show how in the backend the data centers are located. Okay, when you go for cloud computing. So AWS data centers are located in all these locations around the globe. This also is a live source. The source for this has been given here. You can go and check this out on the Amazon website, or AWS website. And in India, there are two. So orange ones are the ones which are coming soon. And we have a data center in Mumbai by AWS. Okay. Europe is very strict in kind of compliance requirements. That's why you can see many data centers in a small region, Europe, and also in Japan. So can anybody guess what is this orange one here? So which is going to come up? AWS data center. I don't know if it has already come up also or not. Any guesses?
Hyderabad.
Yeah, good, spot on. So that is Hyderabad, another data center for AWS. So why these data centers are there? So there's something called as availability zone. Okay, so that concept is that when that virtual private cloud is made available to you, okay, it is actually going to replicate into two zones. Okay, so and it will be transparent to the user. For example, my zone was Mumbai, okay, but suppose something happened in the Mumbai data center when suddenly because of the rain there is a full power outage, okay, I should not be impacted. So then it goes to the another availability zone. I'll be serviced by probably the Hyderabad or the nearest other availability zone, and there is this replica happening. So that makes the service not go down and may be available all the time, anytime, anywhere concept. So a lot of things happen in the background. Okay. So here is how a web application gets hosted in Amazon Web Services. Okay. So the DNS, okay, so I get an IP address and I get serviced by, so let me go back see whether my website is launched or not before and then we'll come back to this. So when I come back, I had just clicked and you can see that the instance is now launching. Okay, so let us go and see here. Okay, so it is running now. Okay, and when I click here, I can see that a lot of things have been made available to me. And as you can see, there is a public IPv4 address here. Okay, and we'll see whether it is available for anybody to use or not. Okay, it's a blog. Okay, as I said, it's a WordPress blog, and it's just called Hello World. And I would be I would say that you guys can also go and check this out, okay, whether it's really there or not. So this is the chat. Is there a chat here option to chat? Yeah. So let me put this. Okay, you guys can go and click this and check this out, whether you are able to access it or not. Whether I'm bluffing or not. Okay, and what I will do is probably I'll go and get the admin access. So it's a WP /admin should be good enough. And I'll change it. Okay, the password I need to get from this instance, okay, that I have. Okay, let me get into this, sign into the console. So please don't log into the admin console. So this is a WordPress admin console, and you can see that I have only one one site here. Okay, posts. You can see all posts. So this is I'll not click on that. I will probably quick edit. Okay, instead of hello world, I'll call it as welcome to CUSAT clubs. Okay, and let us see update, and we'll see whether it gets reflected on the website that we have seen. So you guys can go and start posting. Okay, if you want. Okay, you can see that it says welcome to CUSAT. So it's a live website that I've launched within minutes. Okay, and that's the demo for the cloud computing. And you guys can go and post, and I will be able to see from here all posts. You can go and put your comments, I would say. Okay, and I should be able to see here. Okay, what all posts are there, what all comments people have put, and all that. Okay, no. So people are not so adventurous enough to post, but you can post it, and then we'll see. And every minute that I'm running that, I'm getting charged. Okay, so let us get back to this quickly so that I have a little bit time. So there is something called as the auto scaling. So if the number of users for that website keep on increasing, it will be scaling the EC2 instance. Okay, it will have multiple servers configured. So there's something called as the container concept, which so this through. So I also had a so though it's a website, I also got a domain name for it. Okay, it's there in the console, and this website needs a backend database for all the data that is being stored in different posts, and it also needs an RDS server for each user's configuration and all that. So all that is getting, so everything is getting scaled. And the S3, okay, so S3 will be actually hosted outside. As you can see, it is not part of this virtual private cloud. Okay, and there is this availability zone A, which is this first gray box, and the availability zone B, which is the another gray box, which gives you the high availability. If one goes down, the another will be available to service you. Okay, so what is the shift to the idea account? So what I wanted to tell that everything is undergoing transformation. There's something called the digital transformation. All traditional processes, business processes are getting digitized. Okay, and this is fueling the digital transformation. And because of the digital transformation, IT transformation is also happening. So IT, it's the traditional IT which procures systems, builds a database, a data center, and manages the data center. It's all getting now with the power of things like cloud computing. It's all getting into software managed. You can code and manage the whole software, because by sitting here I was able to launch a Linux machine with a website on it within few minutes, as I demonstrated. And same kind of thing can be done in a private cloud also. And this IT transformation is creating new markets and new services. Okay, so all you need is an idea. For example, if you guys use Instagram, I don't use Instagram. I don't have Instagram nor Facebook. But if you use Instagram, Instagram was an idea by just 2 engineers, and they launched it. It's a free service. I think it's still free. And one day Zuckerberg got the idea that this has a huge potential. He flew and offered to buy that company, and at that time he paid $2 billion, so $1 billion for each of the developers, and he bought that company. And you can imagine what is happening now. Okay, so he's making the market valuation for Instagram right now is 50 billion. So he realized that, and he quite early, and he made money out of it. And it was just an idea. So you just need an idea, okay, to make money or to make your dream come true. Okay, you don't have to have infrastructure, because cloud computing gives you that infrastructure. Even a person in the remotest village can now dream of doing things and make it happen, because as I showed you, you just have to pay for how much you consume and not how much you need for procurement. And there's a lot of explosion of devices, Internet of Things, that is bringing in new ways of thinking, new ways of managing things. Okay, so there's a data exploration. So let me just summarize what we covered today. We covered what is virtualization versus the cloud. Okay, and virtualization is a platform for which the cloud is made on. Okay, and so cloud is not virtualization. Okay, benefits of cloud computing: no capital expenditure, more agility, unbound scale. You can scale up, scale down, customer control, migrations, and resilience. It's always available, and pay for what you use. What I showed you was AWS. We had the EC2 and the S3 VPC, Virtual Private Cloud. The same thing is called Cloud Virtual Networks in Google world, and it is called Azure Virtual Networks in Azure world. So the same things are there in also. If you know one cloud, you can easily work around the other cloud also. Some resources: Cloud Guru is the top portal for learning about cloud computing and going to the next steps. Linux Academy is another one. So if you don't want to spend money, okay, these people actually create the. So for that AWS, I had to give my credit card, though my credit card got charged for just 2 rupees, and then they reverted back. They give you 720 hours of free tier, which I'm using for this demo. But if you don't want to do that also, if you're hesitant to give your credit card, okay, you can use these learning resources, which actually give you a small account. People who have taken GCP would know that. So, and there are other for reference architectures for different use cases. For example, IoT based solution or analytics based solutions, you can have different architectures being deployed. So for example, I deployed a WordPress like that. You can deploy and play around with things. There's something called as a serverless. Okay, so serverless is a concept for web services, and how do you don't have to worry much about where it is running and all that. So that's called serverless. And that's all I had. Okay, so I'm open for questions now.
Thank you so much, Rupesh, for that wonderful session on cloud and the demo as well. Guys, questions please. if you have any questions regarding anything, it could be cloud, it could be resources for cloud, it could be about the jobs related to cloud. Whatever questions you have, please do ask. Yes, everything clear? Any questions? It would be
Yes.
about jobs. Yes, please go ahead.
Good morning, everyone. So my question is there any advantage or is there a preference in the market for AWS or GCP? Like why AWS is already in the market and GCP is still catching up? Is there an advantage over any of the cloud computing companies?
See, when you do business, all that matters is how much cost you incur. Okay. And right now there is no preference. Okay. Because the services provider are almost the same by both providers. AWS has been there in the market, so it knows the domain of cloud computing, what can go wrong. And so there's something called as SRE. I don't know if you guys cover that in your syllabus. It's called Site Reliability Engineering. Okay, it's a whole domain in itself, how you make things available all the time, what all goes. So this called SRE. There are many. There's a Google book also freely available called SR, Site Reliability Engineering, and Amazon has mastered it. AWS is catching up. But AWS has mastered it. GCP is catching up. So GCP also is quite mature. The Google search never went down for us. Okay, for all these decades. So they are using that technology, all that they have used for their various services to make things happen. It's not that AWS never went down. AWS also went down. Okay, and it brought down many companies. Okay, so it shut down many companies. You won't believe, almost 120 companies were shut down when AWS went down for 4 hours. Okay, it's such a competitive market. Okay, you need to be available all the time. You lose one customer for 1 hour, you might lose many customers because it's the word of mouth. So right now there's no preference. Both are giving good services. GCP is trying to capture the market with lower rates. Okay, so if you go and see the rates, okay, per hour rates, it's GCP. So let us see. There are papers which say that over long term, okay, the cost of, there's something called as total cost of ownership. Total cost of ownership actually does not make so much financial value when you go for a public cloud. So people go for private cloud actually. So Azure is one thing which you are forgetting. Okay, many people use Azure. Okay, if you see my market share graph, around 25% people use Azure. There are people who are very fond of Microsoft technologies, and that works very well in the Azure cloud.
Yes, but what I actually wanted to know is from a study standpoint, because like ma'am mentioned, we had a program GCP in our college. Yeah. So via that program, I came to know about cloud and I'm interested in it. So I was proceeding with all the knowledge in GCP only, but with the people who have already not mastered, but know much more about cloud computing than me, they were recommending that you should switch to AWS so that you'd know more. So is it appropriate to switch, or I should go with the thing that I'm familiar with? Like I'm a little bit familiar with GCP. So I should practice or make projects in that domain, or I should switch to other services, not only AWS, Azure as well. So is it appropriate to switch, or first of all, I should learn everything, then I would later decide which field to go on or which company to master on?
From a skill set perspective, okay, AWS is more valued in the industry. Okay, if you get AWS certification, you'll get more interview calls. Okay, GCP is slowly gaining market share. So GCP skill sets are also important. If you go for the top certifications which are there, the GCP certification is quite rated high. But then those are for advanced certification. For example, you want to become a cloud architect and all that. So AWS cloud architect is definitely more valuable than GCP cloud architect. I would say learn one thing properly. Okay, the concepts are almost the same as I showed you. Okay, so it's not going to matter whether you learn one and don't learn the other. There are people who are looking for, because GCP is gaining market share and it is investing a big time in India. It is looking for people who are GCP aware and GCP able to work on the GCP. Azure is another thing which Microsoft is pushing. A lot of companies I know who are startups are fully on Azure. Okay, I don't know if guys know of a company called Udaan. Okay, Udaan is a B2B company which was started by ex-CTO of Flipkart. Okay, Amod Malviya, he was my junior in school. It is $1 billion company. It's a unicorn company, and it caters to only the business-to-business segment. It is fully on Azure. Okay, and since I knew my friend from Google wanted me to talk to them and get the account, but they didn't budge at all. Okay, so Azure is also something that you might consider. Both Azure and AWS are old. GCP is new. You can learn any of this, but recommendation is in the order of AWS, Azure, and then GCP. Did I answer that?
Yes.
Any more questions, anybody?
Yes, one more.
So one technology, if you want to be relevant for the next decade, okay, it's not just about cloud. Okay, it's blockchain. Okay, so blockchain as a technology, it's not about cryptocurrencies, but blockchain as a technology, you should try to learn. And it is already in demand, but you cannot even think of the salaries that they are offering for blockchain developers. And it is new. So whether I start after almost like 20 years in the industry or you start, okay, it's almost the same. So blockchain is something that you should consider learning.
We are actually in the new syllabus, Rupesh. The permanent faculty have actually put blockchain as one of the subjects. So hopefully that is towards better syllabus. Yeah. So anybody else? Any questions?
Yes, one more question I have. So as you mentioned that the virtualization is limited by the physical aspect of the services
Hardware,
that we are offering. Yes, hardware.
Yeah.
So while virtualization, suppose we are just doing on my laptop, I'm providing a part of my resource to the virtual machine that I'm running.
Yeah.
But in the case of cloud computing, like in GCP, whenever I launch a virtual machine, I have the option to choose a CPU. So my question is, those computing powers, those are actual CPUs, or how can an instance of a complete CPU be made which has the characteristics of the CPU that are mentioned over there? Like if it's mentioned 4-core CPUs, then how that specific instance is made?
So it's all virtual CPUs. Okay. So when they mention when you see a real CPU, okay, if you open your computer and see the properties, you'll have the megahertz mentioned there. But none of these clouds will mention how much megahertz that CPU is. Okay, because it's a virtual CPU. It's the number of cores that. So it's all a virtual core that is available. The virtual machine, virtual box that I showed you, even there, I could allocate 2 virtual CPUs for my VM that I'm hosting in my laptop. Okay, so like that in GCP also, when you mention 4-core or 2-core, it's all the virtual CPUs that are getting allocated to you. Was that the question?
Yes, sir.
So at the back end, there'll be one server which will have like 250 cores and all that, and there'll be another server with another 250 cores, and like that there'll be a whole almirah or a full row of almirahs all connected together, which are all part of one something called as a cluster. Okay, so that cluster interface, for example, the VMware ESX actually provides you to club multiple resource pooling, which I was telling earlier. It pools the resources and makes you available what you want. Okay, so you can instantiate probably 10,000 virtual machines from those clusters. So we talk at that scale. Okay, for example, I don't know if you guys use iPhone, and also iPhone uses iCloud, and iCloud is hosted in GCP. Okay, so this many people don't know, but the backend is probably provisioned by a cloud vendor, or you can have your own hardware also.
Okay, thank you for that. Anybody else? Any questions? Yes, no. Rupesh, I just wanted to know. So, if somebody is interested in cloud, this is for my students. I mean, just asking a question. So there are so many different. You can become a cloud architect. So there are so many different ways you can go for cloud. So can you just give some of the designations that they could go for, like when they go for cloud? So some of the job prospects that are available when you learn cloud?
Yeah, so cloud, so there's something called a solution architect. Okay, so AWS gives this AWS solution architect associate. So for example, all these associate certifications, for example, the AWS Cloud Solution Architect Associate will cost you $150, but right now they are having a campaign, okay, to have that certificate at a 50% discount. So if you spend $75, you can become an AWS Solution Architect Associate if you pass the exam, okay, and they are giving free training also. Okay, and so you start with an associate, and then there are specialty levels. For example, AWS security is one security certification is one specialty, but you need to at least know basics to get into the specialty certifications. And there's something called as AWS solution architect professional, okay, which is the next level of the associate. And I think for professional, you need to be an associate before you take up the professional exam. So those professionals are actually $300 and all for AWS. GCP has almost the same set of kind of learning curves. Okay, for example, I cannot show this. So this is the GCP pamphlet. Okay, you can see. Okay, no, I can probably pass it on. So you have the GCP professional cloud architect, okay, then cloud engineer, and there are certain domain specific things like you want to become an analytics expert in the cloud. Okay, so but I would say instead of going for those cloud specific certification, the domain is what people should identify what interests them, okay, in computing, whether they like core computing, okay, or they like analytics, or they like so cloud is another way of just making that computing made available in the cloud free of cost. Okay, but the domain matters a lot. Okay, even if you know cloud computing and you don't know the domain, it is not of much use. So
so now you said like there's cloud engineer, there's cloud architect, cloud security. So all these, if you would need a certification, right? If you have to work in them, or you can just with your domain knowledge, you can you
can go there, and because this basically you should know how to deploy things. So you should know coding, okay.
Yes.
And if you know coding, you can go and code on the real hardware or in the cloud. Okay, so though there's a lot of hype around cloud computing and all, it is just making the traditional computing available in a more agile or in a more comfortable manner is what I would say. So concentrate on the domains rather than learning about, but you should be aware of what is this cloud computing. So session I gave, and you can experiment. A lot of people give free trainings. Don't hesitate to give your credit card there for the free tier. Okay, have a notification enabled. If you get charged, you'll get charged only a little bit, but have discipline to turn off your VM. For example, the WordPress blog that I launched, okay, I would bring it down in an hour or so. So I got so because you get charged for every minute, every hour. I have 720 hours free because I created this account recently just for this talk. So GCP has a good, everybody has, okay, even the Azure has. My slides which I sent, that has got the whole Azure thing also. But that Cloud Guru is one website which will give you good insights on how to go about these certifications.
Okay. All right.
The first link there, cloudguru.com.
Yeah, Cloud Guru. Okay. So thank you guys. Thank you for coming. Please do fill in the feedback form. We do need the feedback form. That helps us understand things better and helps the speaker to get the feedback. So thank you so much, Rupesh, for giving this enlightening session. It was really nice. Thank you so much.
Okay,
thanks
welcome.
a lot.
Bye. Have a good day.
Take care.
Bye.
Take care. And all the best, guys. You guys have your exams coming up on Monday, so best of luck. Do well. We'll meet up next. So next Saturday, there's no session. It's only after exams the sessions will start. So thank you. Have a beautiful weekend. See ya.